Welcome back to Chapter 6. We're now looking at Section 3, which is going to be talking about dividing polynomials. Dividing polynomials is something that we are going to be using consistently for the next few sections because we're going to be factoring. Division is an important part. Today we're going to be looking at long division, which we won't be using so much in the next little bit, and we'll be looking at something called synthetic division, which will become like a warm, snuggly blanket to you. So, let's get started by looking at our learning targets for today. Our learning targets. I can use long division to divide polynomials. And I can use synthetic division to divide polynomials. Just the two ways of dividing polynomials. The long division we'll look at, it's just like long division with numbers, which is both good and bad for you. And synthetic division is much easier, much quicker. And in class after your activity, I'll show you the speed that you should be aspiring to in doing synthetic division. So, starting with long division. As I mentioned, long division is just like the long division you learned in about 3rd grade with dividing numbers. That's the good news. The bad news is that chances are a lot of you are thinking, I don't remember how to do it. So let's look at dividing numbers. Two random numbers. Let's divide 75,483 by 19. That seems unpleasant. One thing I learned here is that my equation editor doesn't actually have a division sign. So we have, where's my mouse? Laser pointer. We have the division and then the bar on top. That's what I can do for a division sign. Sorry it's not an official division sign, but we'll figure it out. And so, how do we divide these numbers? Well, you see, how many times can 19 go into 7? Well, none. So how many times can 19 go into 75? Let's make a list. Let's see, 119 is 19, then 38, then 57, then 76. So 19 can go into 75 3 times. 3 goes up top, and then we take 3 times 19, and we put it on the bottom, and we subtract those numbers. 75 minus 57 is 18, and then bring the rest of the numbers down. Alright, well, then, how many times is 19 go into 184? Well, we know that 4 times gives us 76. Let's expand this a little bit further. 95, 114. So each time we're just adding 19 until we get up to 10. 10 is the highest you should have to go, because otherwise you'd be in 2-digit numbers, and that doesn't work. So 171 is less than 184. So that's 9 times. 19 goes into 184 9 times. So you can put the 9 on top, and then multiply 9 times 19 to get 171. We're going to subtract that to get 13, and then bring down the 8 and 3. How many times does 19 go into 138? We already have all of the 19s over here, so 138, that's 133. And so that was 1, 2, 3, 4, 5, 6, 7 times. So you have 7. 7 times 19 was 133. We already have that multiplication there for us. Subtract. We get 5. Bring down the 3. How many times does 9 go into 53? 2 times to get 38. And subtract the 38 to get 15. So now with this number, you had a few things you've done with this number. In the very beginning, you just put R15, remainder 15. Alright, that's something, but we can go on from there. After that, you learned, hey, we could put a decimal, 0000, and we can figure out to some decimal points, which is great. Not going to be helpful with polynomials, though. Another thing you can do, we had 15 left over. Well, out of how many? We had 15 out of 19 left over. we're just going to make it a fraction, 15/19. So we have 3,972 and 15/19. And so again, how many times does 19 go into it? It's up at the top. We multiply, subtract, and we just keep going. So let's see how that works with polynomials. Here we have a polynomial, x to the fourth minus 3x cubed minus 7x minus 14 divided by x minus 4. First thing we'd want to do is write it in the other form with this symbol instead of this division symbol. So we get it written, and we want to know how many times does x go into x to the fourth. That's a tougher question to answer. A better way to ask that question, instead of how many times does x go into x to the fourth, what times x equals x to the fourth? And so, if we look at what times x equals x to the fourth, well, let's see, we don't have any numbers to deal with. So we have 1x, we need 3 more x's. That would be x cubed. So x cubed times x equals x to the fourth. That's going to go up there. Notice I didn't care about that 4 right now. It's minus 4. We're only looking at this first number. So we get that. Now, just like up here, we had 3 times 19 was 57. X cubed times x minus 4, here's where we use the minus 4, is going to equal x to the fourth minus 4x cubed. Over here we subtracted, so we're going to subtract. And when we do that, x to the fourth minus x to the fourth goes away. That's by design. If that doesn't go away, then you did something wrong. Negative 3x cubed minus negative 4x cubed. It's plus 4x cubed. So negative 3x cubed plus 4x cubed is just x cubed. We have x cubed. We're going to bring down the rest. And notice here we have 0x squared. You don't actually have to have that there, but it's nice to have at least a space so that your work's not going to get all cluttered. So we have the x cubed. We can bring the rest of it down. And rinse and repeat. What times x equals x cubed? Well, x times, we need 2 more to get to that 3, so x squared. Put an x squared at the top. We're going to multiply x squared times x minus 4 to get x cubed minus 4x squared. Subtract. X cubed minus x cubed is going to go away. Again, that's by design. And then minus negative is plus 4x squared. Nothing plus 4x squared is 4x squared. And we can bring down the rest of it. Rinse and repeat. X times what equals 4x squared? Well, we're going to need the x to make the x squared. But we also need the 4 because we don't have any number. So times 4 would give 4x. Times 4x will give us 4x squared. Multiply 4x times x minus 4 to get 4x squared minus 16x. Subtract 4x squared minus 4x squared, 0. That's plus 16x, so 7x plus 16x is 9x. And then bring down the minus 14. Once again, rinse and repeat. Notice how we're doing the same thing over and over and over. It's called the long division algorithm. The algorithm means it's just that process. We do over and over and over. It doesn't matter how big something is. It's just that same step. X times what equals 9x? X times 9. So, plus 9. Multiply. We get 9x minus 36. Subtract. The 9x's go away. Negative 14 plus 36 is 22. There's our remainder. And so we're going to do the same thing. Here we had 15 over 19 because that's what we're dividing by. Now we're going to have 22 over x minus 4 because that's what we're dividing by. So plus 22 over x minus 4. We actually have to add here. Here this is adding as well, but you don't have to worry about that because you're adding it to no fraction. So this is our long division algorithm. We are You know, this first thing times what equals whatever you're dealing with. That goes on top. We multiply, subtract, bring down the rest of it. First thing times what equals that goes on top, multiply, bring down the rest, etc., etc., etc. So let's look at another one. Oh, I just rewrote the answer because my answer is all bunched up. Not a bad idea to rewrite the answer as one solid thing. Alright, so next problem. We have 60 minus 16y squared plus y to the fourth divided by 10 minus y squared. Rewrite it as in this form. Notice I left room here. Also notice I put it in standard form. That is going to be crucial. Is it possible to use long division when it's not in standard form? Maybe, but I would not recommend it. Also, notice that minus y squared, I kept the negative with the y squared. Alright, so negative y squared times what equals y to the fourth? We need a negative to make it positive, and y squared times y squared equals y to the fourth. So we have negative y squared. We're going to multiply that. And notice I put my like terms underneath each other. Apparently I didn't need to leave a space here for the y cubed. That's okay. I would rather be safe than sorry. Next step, subtract. So we're going to subtract the y to the fourths. Go away. Again, that's by design. Then remember to distribute the negative. This is 16y squared plus 10y squared is negative 6y squared. Bring down the 60. Negative y squared times what equals negative 6y squared? Well, all we need there is a 6, so times 6. Multiply. 6 times negative y squared plus 10 is negative 60y squared plus 60. When we subtract, we're going to end up with 0, which means we have no remainder to deal with, so our answer is just right up here. Negative y squared plus 6 is the answer. Now you might be thinking, wow, this problem was a lot shorter than this one over here. This one was super long. Yes, it was. I did that so we could see the steps over and over and over again. So the first couple times, you might not have been following along very well. But by the time we got to the end of it, hopefully you were picking up on what we were doing. So, let's see. Go ahead and try one. Try 2x squared plus 10x plus 8 divided by 2x plus 2. But try it on your paper. Pause and come back when you're ready. Did you get it? Did it come out nice? So, first step, rewrite it. So 2x plus 2 divided by 2x squared plus 10x plus 8. And then 2x times what equals 2x squared? Just all we need is an x. Multiply. We get negative 2x, or 2x squared plus 2x. We're subtracting. So we do that. We end up with 8x. We bring down the 8. 2x times what equals 8x? Well, 2 times 4 equals 8. So we have plus 4. Multiply and subtract. And we get 0. So our answer should just be x plus 4. Are they all going to be quite this easy? Possibly not quite that easy. But most of them aren't going to look quite like this either. So that's long division. It's a big algorithm. You just repeat it over and over and over and over and over again. That you'll do today a bit, but as we're getting into the chapter, we won't do it as much because we're going to be trying to factor. When we try and factor, we're trying to get linear binomials, kind of like this 2x plus 2 or x minus 4. We're not going to be as concerned about things like 10 minus y squared. So, for that we have another method called synthetic division. Let's take a look at synthetic division. With synthetic division, we can do problems like this one that we just did on the other page. Right? We just went through this problem. We're dividing by x minus 4. That's key. It has to be a linear binomial. We can't have x squared. We can't have x squared plus x plus 2. It has to be x plus or minus a number, or something times x plus or minus a number. So let's look to see how we do it. The first thing, we want to take what we're dividing by, and let's pretend it's equal to 0. X minus 4 equals 0. What will x equal? X equals 4. This number is the number you're going to put into our synthetic division. Our synthetic division, we're going to have a different symbol. Instead of this one that looks like that, we're going to have a little half box in the corner. My program, again, didn't have a half box. This would usually be a little bit longer, but that's okay. And this number is going to go right there. So it's 4. Most of the time you have x minus 4, all right, it's going to be 4. Where this is handy is when we have something like 2x minus 4. So we'd add 4, so 2x equals 4, so x would equal 2. We'd put a 2 there. 3x minus 4. So 3x equals 4, so x would equal 4/3. This would be 4/3. And so that just helps us figure out what that number should be, because that's one of the biggest problems people have with this process. So we have the 4 there. Then here, we're going to put the coefficients of our other part of our division. And the coefficients, remember, are just the number in front. We're going to strip the variables away, so it's very important that we keep every variable place. So here, even though there's no x squared, we have to have x squared down here. So we're going to have a 0 in that place. So when we write our coefficients, we're going to have 1, negative 3, 0x squared, minus 7x, then minus 14. And we're going to put a line under it. We have to skip a line because we're going to put stuff here. So now the process of synthetic division. This first number, we're just going to take it straight down. It's just going to go straight down below and end up down there. Now, with the number down here, we're going to multiply by this number. In our case, it's a 4. And it's going to go right up there. And then we're going to add these two. Negative 3 plus 4 is 1. Then again, multiply by this 4. 1 times 4 is 4. Add. 0 plus 4 is 4. Multiply. 4 times 4 is 16. Add. Negative 7 plus 16 is 9. Multiply. 9 times 4 is 36. And add to get 22. Do these numbers look familiar? The 22 should. It's like, oh, 22 is right here. Well, let's see. Then we had 9 and 4 and 1 and 1. Weird. It's those numbers right there in that diagonal of the previous problem. Also notice 1x cubed, 1x squared, 4x plus 9 plus 22 over x minus 4. These numbers become the coefficients of our new polynomial. The question is, what variables do they get? Well, we're just going to start at the top and go down, and we're always going to lose 1 degree. So we start out with x to the 4th. Here we're going to start out with x cubed. So we're going to have 1x cubed plus 1x squared plus 4x plus 9 plus the remainder, 22 over x minus 4. This last step is the remainder, and that's going to be very important for what we do. A lot of times, we won't even care what the rest of this is. We're just going to be looking for the remainder, and we'll talk about that a little bit in a couple minutes. From here, I would just simplify. We don't need the ones, and so just x cubed plus x squared plus 4x plus 9 plus 22 over x minus 4. So notice, each way we got the same thing. This one will always take exactly 3 lines. This one, the bigger the problem, the longer it's going to take. So let's look at some more synthetic division, because this is kind of weird. So let's look at this one. X to the 4th plus 6x cubed plus 6x squared divided by x plus 5. So we're dividing by x plus 5, which means that we're going to need a negative 5 in here So we have -5, and then our coefficients 1, 6, 6x squared, 0x, plus 0 for a constant. Again, it's important we have those. Otherwise, we'd be dealing with 1x squared plus 6x plus 6. So it's important that we include every place from wherever it is we start. So we can draw a line. This first number comes straight down. So it's a 1. And multiply by -5. Is -5. Add 6 plus -5 is 1 times -5. Add is 1 times -5. Add -5 times -5 is 25. Add, we get 25. So again, bring it down, multiply, add, multiply, add, multiply, add, multiply, add. And this is going to be a process that you're going to do a lot. You might be doing it 3, 4, 5 times in one problem. It's going to get very, very quick. It probably won't be right now, but it will be very, very quick pretty soon. So we have these coefficients. Now let's just put our variables with it. We started out with x to the 4th in our problem. We're dividing by a linear deal, so we're going to lose 1 degree. We're going to have x cubed. So this will be 1x cubed plus 1x squared plus 1x minus 5, and there's our remainder. 25 over x plus 5. Just clean up, we don't need all the 1's. And so we can have something like this, x cubed plus x squared plus x minus 5 plus 25 over x plus 5. So, try one, see if you can do it. Try x squared plus 5x plus 6 divided by x plus 1. Go ahead, pause this, and come back when you're ready. Alright, how did you think you did? So you don't have anything to worry about zeros in here. Do we put a minus 1 over here? Then we have 1x squared, 5x, and 6. Draw our line. The 1 comes straight down. Multiply by -1 is -1. Add is 4. Multiply is -4. Add is 2. And so let's see, we start out with x squared. So now we're going to have 1x plus 4 plus 2 over x plus 1. Is that what you got? Did you do it? Did you see your mistake if you didn't? The next thing that we're going to look at is called synthetic substitution. It is synthetic division. It is. That's all that it is. So let's look at synthetic substitution. It uses what's called the remainder theorem. And the remainder theorem, all it says is that when you divide by a linear binomial, the remainder will equal what you would get if you plugged it in, or P of A equals R. So when it's, if it's a 0, the remainder would be 0. It's actually a factor. We'd get 0. But the same is true any other time. And so this doesn't necessarily make sense. Let's see it in action. If we looked at one of the problems that we just did. So we plugged in -5. Well, that would be x equals -5. That would be like plugging -5 into this polynomial. What the remainder theorem says is if we plug in -5, we are going to get 25. Let's try it. We can plug in -5. So we have -5 to the 4th plus 6 times -5 cubed plus 6 times -5 squared. Deal with the exponents. 625 plus 6 times -125 plus 6 times 25. Okay, then multiply. 625 minus 750 plus 150. Well, -750 plus 150 is just -600. 625 minus 600 is in fact 25. So, yes, we can plug it in, but this could be much, 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 much quicker. And it also gives us the rest of the factor as well. So, let's look at a synthetic substitution problem. we have our polynomial, p of x equals 4x cubed minus 5x squared plus 3. And we want to plug in for x equals -1. We're just going to use synthetic division. Notice here we already have x equals -1. So we're going to plug -1 in on the side of our substitution. We don't have to worry about changing the sign. And then get our coefficients: 4, -5, 0, and 3. Synthetic, or pull it down, 4, then multiply to get -4, add to get -9, multiply to get 9, add 0 plus 9 is 9, multiply to get -9, and then add to get -6. -6 is the answer. If we plug -1 into this, we're going to get -6. So the answer, p of -1 equals -6. That's synthetic substitution. It's the exact same as division. It's just we don't care about all this stuff. All we're looking for is a remainder. If you wanted to check that, you can plug in -1. That's negative, so that's -4. That'll be positive, so -4 minus 5 is -9, plus 3 is -6. Synthetic substitution it's something that we do. It has to do with synthetic division. It's not a huge topic in and of itself. I mean, you'll be doing it without knowing about it, but it's super easy, and it's just another application of synthetic division. So, with that, we had long division, we had synthetic division, then synthetic substitution. It's kind of weird. It's kind of long. It's kind of stuff that we're going to be doing for the next few sections. And synthetic division, like I said at the beginning, will become like a nice warm fuzzy blanket for you, and it'll feel so good. So, I'll see you at class, and be prepared to do a quick group activity. Don't forget to comment.